Adding, subtracting, and multiplying polynomials. All right, here's your state standards and your success criteria. You need to be able to add and subtract polynomials after this lesson. You need to be able to multiply polynomials and use special product patterns. And these special product patterns, these are huge on the ACT. So these are something that I want you to really focus on and get familiar with. You also need to be able to use Pascal's triangle to expand binomials. And the vocabulary today is Pascal's triangle. All right, so Pascal's triangle, the first and last number in each row are 1. So you can see right here, the first and last number in each row is a 1. Every number other than 1 is the sum of the closest two numbers in the row directly above it. So you can see the top 3 are 1, and then 1 plus 1 is 2, 2 plus 1 is 3, 3 and 3 make 6, 6 and 4 make 10. So these two numbers always add up to be the number in the row below it. So 10 and 10, 20, 20 and 15, 35, etc. So this is very easy to create, and we're going to use it to solve polynomials or expand binomials a little bit later. All right, some key ideas. These special product patterns, again, these are huge on the ACT in being able to complete questions quickly. Almost always we see these on the ACT, or at least in years past we have. And pretty sure factoring is pretty big on the ACT, and that's a commonly missed topic. So that's something that definitely you could work on if you are going to be taking the ACT anytime this year. All right, common mistake here. A lot of times people forget to expand the binomial and they just want to add the squared to each term. That is completely wrong. Please don't do that. Please don't do that. Please look right here. If you've got a plus b quantity squared, you've got to have that middle term in there. All right, so when you've got a sum or difference, that gives you the a squared minus b squared. The difference of squares here comes from that sum and difference pattern. But when you square a binomial, or you cube a binomial, you have to have those middle terms as well. All right, so here's an example of Pascal's triangle. And again, we will look at that in one of the later examples. Adding polynomials vertically and horizontally. All right, so a little study tip here. When a power of a variable appears in one polynomial but not the other, leave a space in the column or write a term with a coefficient of 0. That way you won't add two things that are not compatible. All right, so let's first look. It says, the first one says add using the vertical format. So I'm going to have 3x cubed plus 2x squared minus x minus 7. All right, and I'm going to add that to x cubed minus 10x squared. There's no x term, so I'm going to leave a space like it says, and then I'm going to add 8. All right. So this is called the vertical format because you're going to add straight down. Now, if there's no coefficient, that's assumed to be a 1, so if you want to put a 1 there, you can. So 3 plus 1 is 4x cubed. And then I've got 2 plus negative 10. So that's negative 8. I've got negative 1 plus nothing. There was no x term in the second polynomial, so I'm just going to bring down my negative x. And then I've got negative 7 plus 8, which is plus 1. All right, so adding vertically is one way to add polynomials. Another way is to do it horizontally. So let's check out how we would add these horizontally. So what we're going to do is look at like terms and put like terms together. All right, so we're going to have our cubes first. So we're going to have 9y cubed. All right, and then I'm going to do my squares next. All right, so I'm going to do plus 3y squared minus 5y squared. And then my y's will become next. Negative 2y plus y, and then plus 1 and minus 4. All right, now I can add these together because the like terms are beside of each other. So there's only one y cubed, so bring down my y cubed. I'm going to add my squares together. So I've got 3 plus -5, so that's -2y squared. I've got -2 plus 1. Again, there's a 1 if there's no number there. And so -2 plus 1 would be -1y. And then 1 plus -4 is -3. All right, so you can choose the method you like. If you like the vertical format, you can use that. If you like the horizontal format, you can use that as well. Example 2, subtracting polynomials vertically and horizontally. So it says subtract 2x cubed plus 6x squared minus x plus 1 from 8x cubed minus 3x squared minus 2x plus 9 in a vertical format. All right, so it says subtract this from this. So that means we're going to put the 8x cubed minus 3x squared minus 2x plus 9 on top, and we're going to subtract the first polynomial here from this one. So we're going to do 2x cubed plus 6x squared minus x plus 1. All right, and we're going to subtract the whole polynomial. So, okay, a common error is that people forget to distribute that negative all the way across. So in order to not forget that, let's go ahead and distribute that negative. So let's change this to a plus. This positive becomes negative. This positive becomes negative. This negative becomes positive, and this positive becomes negative. So when you distribute the negative, you change the sign on every term in the polynomial. So now we've got 8 minus 2, so 6x cubed. We've got 3 minus 6, so -9x squared. -2 plus 1, when there's no number, it's a 1. So -2 plus 1 is -1x. And then 9 plus -1 is plus 8. All right, B part says subtract this from this horizontally. So I'm going to start with my 2z squared plus 3z, and I'm going to minus, remember I've got to minus everything in the second polynomial. So 3z squared plus z minus 4. All right, once again, I'm going to go ahead and change the sign. I'm going to say plus a negative minus z and plus 4. So it changes the sign. I distribute that negative, changes the sign there. Then I can rearrange these like before. I can put my z squareds first. 2z squared minus 3z squared. And then I've got plus 3z minus 1z. There's no constant term, and then plus 4. So these are together. So I've got -1z squared. I've got plus 2z plus 4. So again, you can use the vertical format or the horizontal format for subtracting polynomials. And I don't really care which one you do, whichever way you prefer, whichever way is easiest for you to understand and make sure that you always get the correct answer is the way I would probably do it if I were you. Example 3, multiplying polynomials vertically and horizontally. All right, so we're going to multiply -x squared plus 2x plus 4 by x minus 3 in the vertical format. So let's start with -x squared plus 2x plus 4, and I'm going to write down x minus 3. So if I'm going to multiply these two things together, I'm going to first multiply the first polynomial by -3. So I'm going to multiply -3 by every term in the first polynomial. So let's do -3 times -x squared. That's going to be 3x squared. -3 times 2 is -6x, and -3 times 4 is -12. Now I'm going to multiply everything in the first polynomial by x, because we have to multiply it by both terms. So x times x squared, remember properties of exponents, a power of a power, same base, you add exponents. So I've got negative x squared times x is negative x cubed. So I'm going to put it out here because I don't have a cubed in the first row. And then I've got x times 2x, so that's 2x squared. And then I've got x times 4, which is 4x. All right, so I'm going to have negative x cubed, bring that down. 3 plus 2 is 5x squared. Negative 6 plus 4 is negative 2x. And then bring down the negative 12. All right, so a part would be negative x cubed plus 5x squared minus 2x minus 12. And now we're going to look at b part. All right, we've got y plus 5 and 3y squared minus 2y plus 2, and we want to multiply that horizontally. So we're going to just put these beside of each other. So we've got y plus 5, parentheses indicate that we're multiplying, so we can put these in parentheses. And then we're going to do something very similar. We're going to multiply y times each term in this polynomial, and then we're going to multiply 5 by each term in the polynomial. So we're going to do 3y cubed. Again, same base, you add exponents. So y times 3y squared is 3y cubed. Y times negative 2y is negative 2y squared. Y times 2 is 2y. Then I'm going to multiply everything by 5. So we're going to have 5 times 3 is 15y squared. 5 times negative 2 is negative 10y. And 5 times 2 is 10. Now, just like before, I have to combine like terms. So I'm going to bring down my 3y cubed. I've got negative 2 and plus 15, y squared. So negative 2 plus 15 is plus 13, y squared. I've got plus 2 minus 10, so that's minus 8y. And then only one constant term, so plus 10. So for b part, you're going to get 3y cubed plus 13y squared minus 8y plus 10. Example 4 is multiplying 3 binomials. All right, so if you multiply x minus 1, x plus 4, and x plus 5 using the horizontal format, we're just going to say x minus 1, x plus 4, and x plus 5, and then we're going to multiply. So you're going to multiply 2 at a time. It doesn't matter which 2 you choose to do first. So let's multiply the first 2 together first. So we've got x times x is x squared. X times 4 is 4x. Negative 1 minus x, or sorry, negative 1 times x is negative 1x. And negative 1 times 4 is minus 4. All right, so then we have that. And we still have the x plus 5 that we haven't used yet. All right, so you can go ahead and combine those middle terms if you want. That way you'll have one less thing to multiply. So 4 minus 1 is plus 3x minus 4, and then x plus 5. Now we're going to do the same thing again. We got to multiply the first term by each of these, multiply the middle term by each of these, and multiply the last term by each of these. So x squared times x is x cubed. X squared times 5 is 5x squared. Now I've got 3x times x, so 3x squared. And 3x times 5 is 15x. Now I've got to do the 4 times both terms, so negative 4x. And negative 4 times 5 is negative 20. All right, combine like terms. I've got x cubed. 5 and 3 make 8x squared. 15 minus 4 is 11x, and then bring down my minus 20. And that would be standard form after multiplying these 3 binomials together. So make sure you refer to these key ideas and look for the common